Okay, so in the previous session we have seen how we can add this strafing and forward facing rotation mode. So if I quickly demo what we have been done previously, so if we have strafing mode, you can see whenever I rotate my mouse, the character is strafing on the ground, and if I try to move, it's the same thing. But if I make it as forward facing, the character is always forward facing and is not sliding through the ground. See, and even if I try to move the mouse, the character will automatically resolve its target direction to be moved. Okay, so I'll keep this thing strafing for now, just for the testing purposes, because then we can clearly see what our cardinal direction animations are, and let's progress from that position or not. Okay, so now what we can do is, since we have our basic cycle animation set up here, maybe we can add some start animation stuff instead of directly jump into the cycle animation, because here you can see from the idle animation to cycle animation it seems like a quick jump. See, so whenever I move to the cycle state, it instantaneously play that animation, but instead of that we can show some starting animation where like the character is slowly moving from idle state to the cycle state, and it will give much more realism for the game. So in order to achieve those stuff, actually I have been added some animations additionally provided from Lyra to our TPS game essentials project folder. So here if you go to the characters, mannequins, animation, Lyra, and inside that folder there is a locomotion folder, and for each element like unarmed, rifle and pistol, I have been added further animations here. For example, I think I can search for start. I can see, yeah, so there are crouch animations as well. We will add those crouching related features later on, but for now we are focusing on the non-crouch animations. So here you can see forward start sort of animation is there. So it's slowly moving from idle state to the cycle state, right? And for each cardinal direction, actually we have these sort of start states, for example, forward, left, right, and backward. So we can use these four animations to drive cardinal direction based start animations. Okay, so let's see how we can do those stuff. Right. First, I think we can add more state to this state machine. So currently we have this cycle animation, and we may need to add some start state, stop state, and pivotal states. So those are some of the dynamic state that we have to drive based on multiple different sources or multiple different states, right? Instead of going from same route again and again. So in order to simplify this sort of transition, actually Unreal Engine 5 introduced these state aliases. So you can use these state aliases to quickly jump from one state to another instead of manually attaching like this. So let's try to detach this transition and move it to this state alias, right? So I'll name this state alias as maybe idle sources, because later on we will be having multiple different idle sources, such as even jumping idle state, things like that. But you may have multiple different idle sources, therefore I'll introduce this idle sources state alias. Then it will show set of states that we can jump from, right? So here in this specific state machine, we have two states, namely idle and cycle. So idle sources, state aliases show those states for us, right? But for now, I just focused on this idle state. So let's try to jump from idle state to cycle state. So I'll make it as true. And now I think we can move this specific transition logic to here. So I'll add a transition state like this, or transition arrow like this. And here we have this thing. So I'll cut that out and add it to here. And I can safely remove this thing now. Okay. Now if I try to play, you can see the transition still happens, right? Okay. So that's the first step from the detachment from this idle state, right? So similarly, instead of jumping directly to the cycle state as the intermediary, we should have start state, right? So let's see how we can add a new start state. So let's add a state called start, and I'll go to the start state first and then go to the cycle state. And I'll remove this transition and I'll align these states further. But if I try to play it now, I can see it doesn't do the proper state transition because these transition logics plus these states has not been implemented yet. Okay, so let's try to implement these states first. So I'll go to the start state, and there let's add what we have been added to the cycle. Yeah, we have added to cycle a sequence player, but for the start state, let's add a sequence evaluator. And for this explicit time, I don't need to expose it as a pin. Instead of that, I can simply make it as dynamic value, and make sure to make this sequence as dynamic as well. And it shouldn't loop because start animation only should play once. And yeah, those are the configuration. And then we can maybe make the method as sync group as well. Yeah, and then we can set up this anim state, right? So on become relevant, let's create a new binding. Maybe we can call this as setup start name play, and I can move it to the anim node function. Right, and then let's convert this node to a sequence evaluator, and let's set sequence, and here let's set explicit time as 0, and then let's return it. Okay, then for the sequence, what we can do is what we have been done similar to these cycle states. So I'll copy the entire thing and move it to the start setup anim layer and plug it to here. But obviously we need set of animation for the start cardinal states. So let's add those things at our SNM set. We have this SNM job. Here we have cycle cardinals. Similarly, let me quickly check my documentation. Yeah. Yeah, let's add one called start cardinals. We can move those up to here. This should be any cardinal data structure. I'll compile, save all. Yeah, as usual, this thing breaks. And this is the thing actually. Ideally, I shouldn't compile this first. Instead of that, this is good to go. This is good to go. This is good to go as well. Then let's save this first. Okay. And now let's go to the BPC component and let's compile. So it's good to go, right? Because ideally, this data related stuff are really bit tricky. Like you have to build it from the root onwards. Otherwise, the higher order references doesn't know the structure of these variables. That's why I have to build from the root up until the data table. And once I saved it, now the reference has been updated. So whenever I go to the BPC locomotion system component and compile it, now it's correctly compiled, right? Yeah, I think this same issue has been happened in that rotation mode setting session as well. So I think you can follow up this same pattern to get rid of that specific issue. Anyway, now we have that start animation in our data table. But why this show has a boolean value? Yeah, because that cardinal direction is somehow not set up properly. So let's save it again, everything, save the data table as well. Yeah, now we have that cardinal data structure. Make sure to go to the component level and compile it again. Yeah, why is that? Let's compile. I don't know, maybe this is sort of a bug actually. I even don't know why it happens. But if I try to add it back and recompile, now it works. Okay, maybe this is some sort of a bug. But yeah, if I try to reset it and compile it again, now there has been go. Okay, yeah, those sort of stuff actually happen when you are developing. Those debugging is a part of programming, so no issue. Okay, so let's try to reset these values again. So unarmed jog. So I'll add that forward, backward, and where is left, right. And similarly, let's add the start state for the forward. backward start, left, not this one, left start, and right start. Okay, so this start suffix mention, that is specific for a starting animation, so you can easily distinguish those stuff by using that specific naming convention. Okay, now we have those start animation. Now we have to go to here. Okay, those are some errors, but that's fine. So first let's go to that, where is it, non-thread save function under set animation data. Give me a second. Yep, we have this set idle and idle breaks and cardinals. That cardinals, let's set a new variable called start cardinals, and maybe I can move this to the anim sequences category. I'll plug this thing. So now we have a reference for the start cardinals. Then let's go to the sorry, then let's go to the setup start anim layer, and instead of this thing, now we can replace it using this thing. I'll remove this one, split the struct, and attach those like this. Compile and save. But it gives some error. Maybe let to use sync group. Yeah, maybe for now let's make it this as do not think. Yeah, now that error has been gone, but later on let's see why it doesn't allow me to give a sync group. But for now, just for the testing purposes, let's make it as do not sync. Okay, and then now we have that setup thing. Okay, now then what we have to do is yeah, let me quickly check my documentation. Yeah, I think we're all good. Yeah, now let's set up that transition from idle source to the start state. So in order to do that transition, we should have set of transition logics. So let's see what are those stuff. Okay, yeah, what we can do is simply we can check whether we have a valid start animation to be played. So if we have a valid animation to be played, then we can play this start animation. Otherwise, maybe we can add another transition to directly play a cycle animation. So first, I think it's better to create a new function to check whether we have valid animations or not. So I'll create a new function called set and invalid. I'll add it to another category called maybe anim set. Right, and then here, let's get our start cardinals and break this thing, and we can simply check whether this is valid or not. So if it is valid, I'll mark this as a valid any. So is valid, forward start. Similarly, let's add 3 of this. It follows the same pattern. And this one is valid, backward start. And for this one, left start. And finally, right start. Okay, now let's plug it to here. Yeah, now we can determine whether we have valid animation for that specific cardinal direction. And let's call this function at where? At set animation data. Maybe let's add a new sequence here. Set anim valid, and let's do that checking here. So if we have a valid anim, now I can jump back to the transition. So if we have a valid anim, then we can drive that specific transition. So maybe let's set a new helper function to check whether we have a valid start anim or not. It's valid start anim, and I'll assign it to the same anim set category. And this should be a pure function because we are simply returning reading and returning specific values, no modifications. So let's get the last below. What is that? What we have at here? Yeah, I think we may have a better name for this thing. Instead of having a local velocity direction, maybe we can rename this as last velocity direction. Right? It make more meaningful. So last velocity direction. And I'll copy that enumeration value. Go to that is valid start anim. Select, and based on this value, I have to check these validities. Right, and I'll assign each of these to another category called anim valid. Maybe anim validities. And let's get one by one. For the forward start, backward start, left start, and right start. Okay, and let's simply return well, right? So this will check whether we have a valid specific anim sequence for a given last velocity direction, right? Then let's go to this transition and add that value, add that function actually. Right. It gives some warnings. Yeah, so make sure to make this as thread safe and compile. So now that there has been gone. And we have one more transition to be resolved, because start to cycle will be never taken place, because we have to add this transition. Maybe we can make this as what? Give me a quick check. Yeah, maybe soon after we played this start any, we can do a jump to here. So I'll make this as automatic rule based sequence transition. Right, now we have all of those stuff. Plus, let's say if we don't have valid start any, then we have to quickly jump to cycle state instead of rely on this state, right? Otherwise, T pause animation will be shown now if we don't have a start animation, right? And for this thing, what we can do is we can simply check if this is not valid, not boolean, then make that transition, right? Okay, maybe I can align this stuff like this so it will be much clear. And yeah, be like this. Okay, we have that start cycle states, so let's try this thing. Not seems like it's not jumping to the start state. Yeah, so here we have to check actually whether we are accelerating or not, because it's just a naive issue, because here we are checking at the very first frame whether we have a valid animation or not, but whenever this state machine is triggering for each frame, we have to check whether we have a possible acceleration or not as well. Otherwise, this state transition won't happen. Yeah, so in order to check whether we have acceleration or not, let's go to the locomotion system component, and for each tick we have to check whether we have a possible acceleration. Yeah, let's create maybe a new function called check acceleration. And this function first let's get acceleration as well, so we have to check maybe let's say get is accelerating, right? This could be a pure function. So since we have this character move component, if it is valid, we can get the current acceleration, and we can check its vector length xy. So if xy length has been positive value, which means greater than 0, then it's probably accelerating. So we can return like this. Right. So I'll push it to the getters category. And at the check acceleration here, we can get whether it is accelerating or not, and if it is accelerating, let's promote it to a variable called as acceleration, right? Okay, and similarly, if acceleration and this one is not equal with each other, we have to only do the checking, otherwise we can keep the acceleration variable as it is. So let's add it like this and like this. Yep. Okay. And then we have to call this for each frame. So at the event tick, we can call this check acceleration function. Right, so event tick is a very expensive function because it is calling for each frame. So we have to make sure we are calling only the necessary functions whenever it's required, right? So maybe we can do optimizations later on, but for now I think this would be fine. So check acceleration, simply check whether we have acceleration or not. If we have acceleration, right, we have an acceleration, what it should do is call a specific event dispatcher event. Maybe let's call it as what? Yeah, let's call it as event on acceleration changed, right? And here we can pass as acceleration, and maybe it would be nice to capture the last velocity direction as well, because later on when we are doing some turn in place animation and stuffs like that, we may need that last velocity direction. So I'll add that as well, last velocity direction, which is a float value. Okay, now we can call that event or event dispatcher here, and I have to pass as acceleration and last velocity direction as well. So how we can capture the last velocity direction? Basically I'll create a new helper function called get last velocity direction, move it to getters and make it as pure, right? So now I have to get the reference for the anim instance as well. So maybe I can add another reference here. So since we have character reference, we can get the mesh reference, and from that mesh you can get the anim instance. Now create or promote it to a variable called main anim instance and move it to the references folder. Right, so let's go to the get last velocity direction function, and we can check whether this is valid, and we can calculate the direction based on the character movement last input vector and the characters base actor rotation. Right, and once the direction has been calculated, we can return that specific value. Okay, so let's go to the tick event, and here we can pass that get last velocity direction like this. Right, so we may need this variable later on, so that's why I pass it here as well. Then we don't need to no need to modify or update these event dispatches again and again. Okay, now we know whether we have acceleration or not, plus whether we have last velocity direction or not. Just for testing, let's add a print statement and run it. Yeah, now you can see when I move that hello is printing, and when I am not moving, hello is not printing. Okay, which means it is properly capturing whether we are accelerating or not. Okay, now let's go to the ABP locomotion, and inside initialization animation, initializations, I'll add a bind for that acceleration changed event, bind event to event on acceleration changed. Right, and let's create an event with a matching event, I believe. Yeah, with the matching event, and we can name this as same event on acceleration changed. So I'll move it to here. Yeah, all the event dispatcher functions or events resides. And yeah, now that reference has been broken because I have been renamed it, so I'll select this one and compile it again. Okay, now let's go to this event and acceleration changed, and if we have a possible acceleration, we can simply play the start anim. So maybe I'll promote it to a variable called as acceleration, and let's move it to the character state data. Similarly, we can use another variable for play start anim. So if we have a valid acceleration, then we can play a start anim. Plus, let's store this last velocity direction data as well. Later on we may need it. Oh yeah, I think we already have that. Yeah, we have that last velocity direction. Oh. Yep. Yeah, I think I have been misreaded the variable name, so maybe I'll keep the local velocity direction as it is. It was my mistake. And now let's promote it to a variable. Sorry, I think I can use this one. Okay, now we know whether we have acceleration plus what is the last velocity direction float value. Okay, then let's jump back to the anim graph, locomotion. Let me quickly look at my documentation as well. And yeah, so in this start animation, we have to check whether we have valid animation, plus let's add and boolean, and we have to be sure whether we can play start anim or not, right? So maybe I can move this to the character state data as well, and if we can play it, then this transition should happen. So now let's give it a play. Okay, it's not playing. Yeah, so actually I found the bug. Well, actually it's not the bug, but I have missed certain concepts when I'm implementing this sequence evaluator. The first thing is actually we are using a sequence evaluator at the start uh, any state. So since we are using a sequence evaluator, I'm specifying a explicit time, which means like what is the exact frame that I should play in this specific animation frame. So here I'm setting it as 0. So whenever this state machine enter to this start state, it will keep showing that 0th frame, and it's not extending or advancing the time for that specific frame. So it will remain on the very first frame, which is sort of like a freezed manner, right? So this is what exactly happening. So if I maybe expand it, you can see if I try to move, now it's remain in that 0th position, and it's not advancing the animation time for it. So in order to resolve it, what I can do is simply yeah, let me quickly check out. Okay, what I can do is I'll create a new binding called update start anim layer, right? So this should be an anim node function as well. And here I'll get the convert to sequence evaluator, and here I can advance time, and for the context I can provide the same context as usual, and the play rate I'll keep it as 1. Okay? So if I compile, save and play now, here you can see now the start animation play, right? But what happened when I'm stop moving, it either remain in the start state, or it can either remain in the cycle state as well, right? So this issue happens because of this check acceleration thing, right? So here I'm checking the acceleration. So whenever I have the acceleration, I'm calling this function, but whenever the acceleration is false, I'm not triggering this acceleration changed function. Therefore the animation blueprint doesn't know whether the animation is not accelerating or not, whether the character is not accelerating or not. So if I show you what happened here exactly, I can make maybe on this function, maybe I will add a print statement for this has acceleration. So if I start playing, you can see it keep printing true, which is again wrong. Plus once the movement has been stopped, it's not printing the false, right? So in order to fix that, what we can do is, instead of calling this thing explicitly outside of this check acceleration function, we can simply remove this thing and move that specific logic to here, right? So soon after this calculation has been started, it will send a request, plus whenever the has acceleration is false, which means it's different from the current state, then again it will send a false signal through this event dispatcher, right? So if I show you what's happening now, you can see the true is printing only once, which is intended, plus whenever we stop movement, it will print the false, and the state has been transitioned back to the idle state. And if I move again it will move and idle. Yeah, yeah. So now the animation is working properly. uh, but yeah, the strafing seems a bit odd for now, but we can change those stuff later on. Yeah. And one more thing we can do, yeah, first let's remove this bug thing because we don't need it now, and go to the anim graph locomotion. So one more thing we can do is we can set these priority orders, because now this idle source is pointing to two different states, but if you look at the transition states transitions priority orders, both are one. Actually, I maybe at the debugging session I have made it to two, but in your scenario it should be one, right? So make it as two, so whenever it do the transition, first it gives the priority to this transition and it will check whether we have a valid transition or not. So if it has not valid start transition, it will directly jump to the cycle state. Then since the priority order is 2, it will check this one, and if we have a valid start transition, then it will make it to here and do that specific jump for us, right? Then once the start transition has been ended, it will jump to the cycle state. Okay. So maybe we can improve this transition further, because whenever we change the anim set, maybe we don't need to start it from the beginning, so we can add that logic to here as well. So if the animation has been changed, then we directly jump, right, without passing to the start state again, right? Maybe I can make this as priority 1 and initialization, and I can make this one as priority 2 and it has standard plane. Okay, now both are fine, I believe. Plus this transition from cycle to idle, maybe since we have since we have this has acceleration function, maybe instead of using this was moving since last update, we can use this thing. So I'll plug it to not, and let's play it again. Yeah, it working as intended. Yeah, so I'll remove this thing and I'll keep this as acceleration as it is. Okay, let's check forward facing as well. Yeah, forward facing work fine, I believe. Yeah, but starting is fine, backward start also fine, start and right start, yeah, both are working pretty much fine. But I think the rotations can be improved, because it seems only for this strafing this rotations has been applied. Yeah, so I think I found the issue. So the issue is basically whenever we in the strafing mode, even if I try to rotate my mouse or the mouse inputs, character is not rotating. So the issue is actually at the data table. Uh, so this rotation rate Z value has been resetted somehow. So I'll keep it as 360. Plus, I think for the safe side, it would be nice if we set this one to 360. Plus, here inside the SNM job, the rotation rate, let's make it as 360 as well. Uh, and finally at here. So among the data structures, we have that specific value. Therefore, this value will get not reset at the future changes, I suppose. So yeah, that was the issue for strafing, and yeah, now let's try. Maybe I'll go in this way. Yeah, now you can see for the strafing it works properly, and even the start animations are working for both cardinal, for each cardinal direction properly. Okay, so thank you. I'll see you in the next session.